New podcasts with high journal appeal using a pure exploration, infinitely armed bandit strategy.
So the research question that we're answering here is essentially how can we identify the most promising content for a recommendation platform? So the reason we care about this problem is because recommendation platforms receive a huge amount of podcasts every month in tens of thousands. So the question is, how can we identify the most promising ones so that we can help podcasters early in their career to reach their potential? So this paper first considers a supervised learning approach to predict audience growth potential, and then we conclude that predicting growth potential and predicting popularity is not the same thing, and in fact, that using features could be misleading. So as a result, we introduce a non-contextual bandit algorithm that seeks to identify content with high growth potential, which we define as content with high general appeal. So what do I mean by high general appeal? Well, we define general appeal as the expected number of users who would stream up the podcast in a controlled randomized trial. And we show that general appeal is a better indicator of a podcast's potential audience size than its popularity signals. But the problem is that we cannot conduct this sort of randomized study, and when we are dealing with tens of thousands of podcasts each month and millions of users because of risk to user trust. So we need to come up with an efficient way to conduct the randomized study. And that's where we introduce a non-contextual bandit algorithm. But we will talk about that in a bit. So first, about our supervised approach, we essentially try to predict the number of streams a podcast will receive 60 to 90 days post-launch. And remember that these are about new podcasts. So we are trying to predict the streams early on in the podcast's life cycle. And we had a baseline that was sorted by popularity that simply ranks based on number of streams in the past 30 days. Our original task was trying to figure out different kinds of signals that help us predict growth potential. First, a few words about our features. So we tried consumption features, things like number of streams, number of followers a podcast has, and also we tried some content features like what was the topic of the podcast, and the episode count, the mean duration, and how regularly the episodes were released. So this is like a very big table. But the main takeaway here is that it turned out at the end of the day, the best approach was, if you want to predict future popularity, look at past popularity. Even its number of streams on the launch day can be predictive of like future popularity, and these signals get more and more predictive of popularity as time passes. And this was surprising because these signals are very early from the podcast's life cycle in the first few months, and especially surprising for those consumption signals to be useful based on the launch day. It turns out that this sort of signals, for example, helps people who are already popular outside podcasting, and for example, celebrities, influencers on social media. So they are transferring their audience once they start podcasting. But these signals will not tell you anything about somebody who is not already popular, and they're creating good content that has growth potential. So the question is, how can we identify those creators or those podcasts? And so we did a randomized study on 700 podcasts, and essentially we showed that streaming is a poor indicator of general appeal. So if you look at the last row of this heat map, it shows that general appeal is only 0.3% correlated with 30-day streams, and it sort of stays there. So this study essentially helped us or motivated us to come up with an efficient way to conduct randomized studies, because it seems like general appeal is a better indicator of growth potential. However, it's not correlated really with number of streams. So yes, we can predict future popularity or future number of streams, but that will not help us find high general appeal podcasts. The reason that, as I said before, that we introduce a bandit algorithm is so that's a more efficient way of conducting randomized trials in a way that minimizes risk to the user. In our case, in our particular case, risk to user trust. So if you have a large number of podcasts or arms and a small budget compared to the number of arms, and your goal is to find the top K arms, this problem could be formulated as a pure exploration infinitely armed bandit algorithm. And that's exactly how we formulated it. And then the goal is to find the top K arms. So for the rest of this talk, I will talk about finding the top one arm, and but the algorithm that we introduced works for the finding top K arms. So a lot of the bandit approaches could be thought of as a test and filter approach, meaning that in each round of the algorithm, you have some number of arms and you test them. And based on the data you have collected so far, you decide and say, oh, these arms look promising, and these ones, they don't look promising. So you proceed only with the promising arms to the next round. And the important point here is that how many rounds you have in practice, it matters. And I will talk about why that matters in a bit. So the algorithm that we introduced is called Aisha, and it's based on a finite arm bandit algorithm called sequential halving. So for us to make this algorithm work in the infinite case, the question was, how many arms do we draw from the underlying reservoir distribution or reservoir of arms? And it turned out, based on a lot of tests we did, that regardless of how hard the underlying problem is, draw as many arms as you can. And for this algorithm, meaning for our algorithm, it meant discarding half of the arms after just a single pull in the first round. And that's quite aggressive, making decisions based on just one sample. But it turns out it works because when you draw as many arms as you can from the underlying distribution, then you can afford to lose some of the arms. So you might lose some of the good arms, but the distribution of arms from round to round gets better. And so that's the intuition behind the algorithm, why it works. But if you want to learn more about it, please, you can find more about it in the paper. So we tested this algorithm on a lot of reservoir distributions compared against a lot of bandit baselines, and some of these baselines had knowledge of the underlying distribution. And still, our algorithm performs better, or it is competitive to the best algorithms. So here I'm showing you examples on movie lens and the podcast reservoir. Our podcast reservoir was simulated from the randomized study on the 700 podcasts that I mentioned earlier. And so the best performing algorithm here is a version of our algorithm called Unforgetful Aisha, and successive rejects and empirical CBT. However, our algorithm has an empirical advantage over empirical CBT and successive rejects, because our algorithm has a lot fewer rounds compared to these two algorithms. And the number of rounds matter because in practice, you're dealing with delayed rewards. So, for example, if you recommend a podcast to somebody, involves human feedback, and It will take them often days to give you back the reward or stream the podcast. So say if that delay was just 24 hours, which is not unreasonable. In fact, it's in the lower end of like the delay for podcasts. And if you have that delay, say you're testing 32,000 podcasts on users, and you have a budget of like 480,000 users. With that 24-hour delay, empirical CBD will take more than 1,000 years to find the best podcast. Successive rejects takes 13 months, and our algorithm takes only 15 days. So our algorithm, not only in terms of simple regret, does well, but also it's more practical. So some final thoughts. Pure exploration bandit algorithms are a good way to conduct large randomized experiments. And because we care about collecting unbiased labels here, we should be careful about using features because they could be misleading. So finding new algorithms that perform well with and practice where you're dealing with delayed rewards is a promising venue of research. Thank you.
So let's see. Apologies to our online viewers for missing parts of the talk, but I think things started working in a few minutes into the talk. My understanding is that Jesse will be answering questions. So there are a few questions on Slido. For instance, how did you create your simulated offline evaluation dataset to compare the Bandit strategies?
Offline data set, what we did was we took the general appeal numbers that we had measured in the online study and treated that as one of the biases of the coins that you could draw from the reservoir. And so each of the podcasts in that study became one possible bias, and then we just sampled biases uniformly with replacement from that reservoir.
All right. Another question on regression, on your regression models. So how come you chose the regression models you chose?
It's just a selection of models that are easily available. We didn't want to dive too deeply into complex, for instance, neural architectures, mainly for the reason that if the model isn't working well already on simple models, it doesn't seem worth investing more heavily in more complex models.
Okay. And how do you identify the number of user samples required to the point we say an item is a cold item?
So you can choose, the way that Aisha works, you choose the budget, the total number of user impressions you're willing to use, and it selects the number of podcasts to sample. You could do the calculation the other direction, say I have this many podcasts, and it would say how many user impressions you would need to measure. So you pick one or the other based on your population. We chose 30,000 because that's roughly the amount of new English language podcasts that show up every month.
Okay. I have a question about the domain. So would an approach like this work for identifying music? So albums and artists that will get many streams?
Yeah, our view is that this non-contextual bandit approach can find sort of the top K best results from just about any random experiment you wish that you could run. That's one of the messages we are trying to convey with this paper, that this is a tool for label measurement that we think is applicable to a broad variety of things. It certainly could find, say, artists that have general appeal as well as podcast creators.
Okay. Thank you again. And now we're moving on to the final talk of today. Andreas Grün will be presenting Translating the Public Service